Hello, we are Spirit Games, and in this project we are developing an SG or serious game that instead of focusing on the playing experience, it's more related to learning while playing. In this context, we will develop a maze game in which the player has to pass different levels of maze and complete didactic puzzles to pass the level.
So I'm going to explain the software architecture. We will be working over SOA, service-oriented architecture. This is an architectural style that focuses on discrete services instead of monolithic design. It is built from a small one or more services that can be deployed independently of one or another. Each microservice can exist as a standalone application, and it is responsible for performing a task. Usually, these services are connected to each other over HTTP and communicate between themselves through an interchange of messages. The microservices approach assures scalability, maintainability, ease integration, and decentralization. This architecture consists of a presentation layer, several web services, and a persistent layer responsible for data storing, like we see in this picture. Each one of the web services is implemented as a standalone application and can be developed and changed independently by others. The game's construction services consist of six web services responsible for a game construction. The maze editor allows a game library to be created or edited and store its structure in a XSD file and in the game database. The maze validator validates the XSD file produced by the maze editor. In this picture, we can see that the user management services includes 4 web services related to management of profiles of different users, and the play game services contains 3 web services. The analytics will provide the data for processing, analyzing, and extracting information from it. The platform is accessible for 2 types of users, the game creator and the game player. Both types of users communicate with the web services through a presentation layer presented by the user interface of the system. So now my partner is going to explain the libraries.
Mm, as a general note, finding the best library or engine for you is completely up to you. So go through the list and pick the ones that sound like the best fit for your needs and level. As an extra piece of information and advice, it is very important to communicate with the developer team since the way they will not do the same work and one and they will not step on each other or sorry or libraries where we have the importable fields for use as replaced by the level creation mode, making it have a minimum waste and fast loading. Uh, Thanks to that, players will be able to enjoy a very well optimized game. And as you can see in this image and in the next image, thanks. Our libraries are the basic Unity libraries, which are characterized by medium libraries in organization and modification. This gives the user speeds and developers a better organization of files for future updates. Finally, instead of a graphic-focused engine for the last library, I wanted to cover something different. Physics ES as, uh, as it is a name state, focuses on the physics aspect of object interaction. You can use this library for game developer, for example, 2D or 3D, or for any other type of simulation you want to create.
As for the programming language to develop the video games, we will use C#, which is widely used in this kind of project. We have chosen to work with C# because, apart from the fact that it is easy to use and learn, it has direct access to memory and doesn't require methods and types to be declared in a specific order. It automatically collects travis to free memory, and it is a powerful language. Also, C# enables robust and durable software development and ensures software evolution. In addition, C# is a great choice for developing video games, as it has specific frameworks for video games, such as Unity or Xamarin. C# can be used to create games on practically any platform, include iOS, Android, PlayStation, Xbox, and Windows. Finally, we will also use extensible markup language, XML, which allows you to define and store data in a shareable way. XML supports the exchange of information between computer systems, such as website, database, and third-party applications.
Algorithms and data structures. The maze are generated automatically by applying a format XML description of the maze, together with unneeded game assets. The maze generation is possible using a custom plugin named Maze Builder and developed for the Unity TCT game platform Unity. For an offline local generation, the plugin should be imported into the Unity game editor as a custom package. Next, it requires entering an XML document valid against the XML schema and describing a maze game, together with an archive of all the gaming assets. Having the XML maze description document and the asset archive, the Maze Builder plugin generates the maze in a few seconds. Game designers need to describe their game formally with an XML document presenting both the learning and gaming contents. The project team develops an online drag and drop maze editor for facilitating the maze design. The editor is controlled by the maze XML schema. It consists of a connectivity editor serving for defining the connections between the maze hull, a property editor facilitating the design of each maze hull, including content for the learning boards, definition of embedded minigames, and all needed gaming assets together with properties of the available NPC.
Regarding the data source, we have a data table with a large capacity of records to keep the data of different results formed by the users who play with this video game. In addition, the data source performs the data search very quickly, give the value to the users as soon as possible. Something like if the player releases one question, it will show the result, if yes or no. Also, we are using Terraform to create different data sources more easily and making it as low rate as possible.